This next video is about iterative statement. It's a counterpart of the previous video where we were delving into conditional statement, and the goal is the same: get you up to speed on how to use iterative statement, which you already learned to use in a different programming language, how to use them with the C programming language. So let's jump into the code and let's take a look. So what we're going to start with is one of the easiest possible loop that you can do, which is a counter control loop. That means a loop which termination is going to be determined by the value of a counter. So I'm going to have here int, let's call it counter after a while. After all, why not? Int counter equals 0, while counter is lesser than, let's say, 5. Then we are going to do counter plus plus. So counter plus plus means increment counter. So I could have written this counter plus equal 1. This is another shortcut notation for incrementing by 1 a variable that is an int. Or counter equal, so counter is assign the value of the expression counter plus 1. So you take the current value of counter, add 1, and you assign that to the variable counter again. Okay, whichever way you want to write it is okay with me. You just need to be aware of the different notation. So we have a loop here that's going to count up to 4. So it's going to go 0, 1, 2, 3, 4. And we are going to double check that by just displaying every time the value of counter. And when we are done, printf \n just to clear the line. So let's save this. Let's see if we can have like some typo in there. So GCC, compiling main.c. Hold on. This is saved. We're switching to this window, GCC. There we go. There was a little problem with the terminal. GCC main.c. All right. And then execute a.out. 0, 1, 2, 3, 4. So this is exactly what we talked about. Okay. So of course, the thing with counter control loop is you have to be careful about your initial value here. This determines where you start counting. Careful about whether you use lesser than, lesser equal, for example. That makes a difference. Let's see about it right now. All of this is review. Okay, you already did that in another programming language. I forgot to compile. This is why it looks the same. Compile, run it. There we go. 0, 1, 2, 3, 4, 5, right? Because I switched from lesser than to lesser equal. And then be careful about, increasing or decreasing your counter here. For example, if I start counting at 0, I expect to go up to 5 included. But instead of incrementing by 1 every time, I decrement by 1 every time. Guess what's going to happen? I'm going to have an infinite loop. Okay. So let's compile and run that. There we go. Whoa, hey, that's a lot of stuff. So it goes very fast, okay? But what happened at the beginning is it went 0, then -1, then -2, then -3, then -4, and it kept decreasing like that until it reached, minus 945,019, and it keeps going like that. And there's no chance that I'm going to reach 5 because I'm going in the wrong direction, right? So watch out about those 3 spots every time you write a counter control loop, okay? The initialization, the condition here, and the value that you want to stop at, and then make sure that you increment or decrement appropriately to be able to one day reach that value. Okay. Back to a version that works. So let's compile it. Let's make sure it actually works. There we go. Now we're back to a version that works, and what I want to do here is I want to underline a few of the syntactical things that you have to be careful about with the while loop. So the while loop exists in every programming language. Okay, this is a very standard statement in any programming language. In the C language, we are in a family of language that uses a curly brace. So you remember what I told you about the curly braces when we went over the if statement, the if else statement. They are optional, but if you remove them, for example, if I do this, I remove the curly brace, okay? No matter how you indent your code, this is not Python, no matter how you indent your code, the C compiler is not going to understand that you want to do both things inside the loop. It's going to say Well, there's no curly brace here. So I'm taking only one statement. I'm considering only one statement, the immediately following statement, as being part of the loop. And then this, well, this is another statement, and apparently you didn't bother putting it in curly brace, so you don't need more than one statement in the loop, so this is going to come after. So just removing the curly braces makes the compiler understand your code differently, as we've seen with the if statement. If I compile this and run it, well, there we go, 0, 0, 0, 0, 0, another infinite loop, okay? So what's happening? We initialize the counter to 0. We check the condition. Is the counter, which is 0 right now, lesser than 5? This is true. Because the condition is true, we enter the loop. The loop has no curly braces, so it consists only of one single statement. That statement displays 0 on the screen, and then we reach the end of the loop. We go back and we check again. Is counter still lesser or equal to 5? Well, counter didn't change. That's the problem. So counter is still 0. 0 is still lesser than 5. So this is still true. And I jump and I display again counter, and I come back here, and you get the idea, right? We're never going to get out of this. So watch out. My advice is, if you know exactly what you're doing, please feel free to remove unnecessary curly braces. If you are not 100% sure, then put the curly braces. That doesn't hurt anything. As a matter of fact, it's a good practice to put always curly braces in the if-else statement and while statement. So there you go, and you are going to spare yourself a bunch of potential bugs like this one. Okay, so we are back to a version that works again. One more thing on the topic of curly braces and stuff like that. What if I get how to say? What if I indent my code like this first? Putting the opening curly brace here on the next line, closing curly brace aligned with it. Well, that's very well. I mean, there's no problem with that at all. So we can indent it like that. The compiler doesn't care. Some people prefer actually when it's indented like this rather than opening the curly brace at the end of the line. I have no problem with either way. Make whichever you like most, your style. I'm okay with it. There's one thing that I need to warn you about. You see how every statement in C ends with a semicolon, okay? So you're going to get in the habit of putting the semicolons everywhere. And everywhere is not actually acceptable. For example, here, this is not the end of the while statement. This is not the end of the loop. The loop starts here with a while keyword, okay? And then there is a condition, and then there is a body of the loop, which can be just one line or can be a block, with curly braces. And only after all of that does my loop end. So if I really wanted to put a semicolon somewhere, because, C has semicolons, I would have to put it here. If I do so, I can compile my program, and it still works the same, okay? But after a curly brace like this, the semicolon is not necessary. You notice that when we end a method, we didn't use a semicolon. When we have an if statement, like if I have something like that, if, blah, 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 open curly brace, close curly brace, else, open curly brace, close curly brace. Well, you never see me put a semicolon at the end here of the if-else statement. So the rule of thumb is when you close a curly brace, you don't need to put a semicolon. You are closing a block of code in effect, and it's understood by the compiler that you're closing the statement. All right, so all this to say what? Well, all this to say that if you get overzealous and you put a semicolon here, you could say, well, it's just going to be like, the semicolon after the curly brace. It's not going to hurt anything, right? Well, let's take a look. So I just added semicolon here, right? So now I'm going to compile. I'm going to run it. And I have a beautiful infinite loop. So what happened exactly? Well, let's take a look together. So int counter equals 0, that didn't change. While counter, which is 0, lesser equal to 5, that condition is true. So I'm entering the body of the loop. And then the mistake that we all make is to look at this and skip mentally the semicolon and think, well, this is the body of my loop. Look at this. There are curly braces. It's indented. I mean, it's obviously the body of my loop that I intended to write. Yes, it's what you intended to write, but this is not what you wrote. What you wrote here by putting the semicolon is you wrote that there is a statement after this part of the syntax of the loop, the while and the condition. There is a statement right here in this orange highlighted box. And it's a statement that does nothing. It's an empty statement. And like every statement, it ends with a semicolon. So that changes a little the perspective, doesn't it? What's happening here is that we have while, counter lesser equal to 5, and then we have exactly one statement after the closing parentheses without curly braces. So that means this is a one statement that represents the body of the loop. So the body of the loop in this example here is empty. It doesn't do anything. Okay, there's nothing. It's that orange box right here, right? So what you do is you check your condition while counter lesser equal to 5, 0 lesser equal to 5 is true. You execute that orange highlight box, which does nothing. And that's the only thing that is part of the body of your loop because you didn't use curly braces. So they are after. And then you are going to go back to the beginning of the loop and test again, 0 lesser than 5, still true. Execute again, nothing. Go back, execute again, nothing. Go back, execute again, nothing. So you have like a nice little empty loop here with a body of the loop that does nothing, and that is one empty statement. So you have to be careful about things like that. Okay, these are like little details, I know, but the devil is generally in the details. And programming is really, you could argue, all about paying attention to detail, because the program is going to follow, the computer is going to follow blindly what you tell it to do in the program. So you'd better be careful about exactly what you tell it to do. Okay, so be careful about those little traps. These are classical traps when you are learning to program, and especially when you're learning to program in a language like C. Why is it such a prominent trap? You know, why do people end up putting semicolon here? Well, it's a combination of two things. It's a combination of, if you put your curly brace here, generally you're not going to write something like that because that looks weird. Okay, something like that looks like a little more common, if you will. All right, every line ends up with a semicolon. Well, look, this line ends up with a semicolon. Your brain is not going to be even raising a red flag, most likely. Okay, but if you write something like this, well, this is weird, semicolon, and then I open a curly brace. Oh yeah, forgot about that. I don't need a semicolon here. Okay, so this is why some people will argue that this is actually a better way of indenting your code. Okay, so that's the first thing going on. The placement of the opening curly brace might play tricks on you. There is another thing going on. For while is not the only loop in the C language. We have another loop called do while. Okay, and I'm going to use the counter control loop here too. So counter, let's do exactly the same thing. You know what? Lesser than 5, and I'm going to tell you, once again what's going on here. So counter plus plus, because I'm lazy, I don't want to write counter equal counter plus 1, so I use a shortcut. And here, before to start the loop, counter equals 0, I reset my counter to 0, and in the middle of the loop, I'm going to display the value of counter. So this is what I'm going to repeat over and over and over here. There we go. So I paused when I reach here, okay, at the end of the while closing parenthesis here. If I try to compile this, the compiler is going to complain that it expected a semicolon before printf. So what is it talking about? It's talking about line 16, and it's talking more specifically about this location here, and this is what it expected. So it expected a semicolon here. So in the case of the do while, you need actually a semicolon to close the entire loop statement, okay? It's because you don't end with a closing curly brace. What you have is a keyword do that say my loop starts here. Then you have a pair of opening closing curly braces that specify, everything that is in the body of the loop that needs to be repeated. And then only after that, you have the while keyword. So it's the opposite of the while loop, right? The test is at the end. And the while keyword is going to test this condition after you executed already once the body of the loop. And it's going to check pretty much if it should continue or not. If the condition is true, rewind, go back to the beginning, do it again. If the condition is false, get out of the loop. And we end the whole thing with a closing parenthesis. And because we don't end the whole thing with our closing curly brace, we need a semicolon. Okay? Little detail, again. But the deal is that now your brain is going to get used to seeing while with actually a semicolon at the end, right? So this is why we draw attention of every novice programmer on this little particular snafu, syntactical snafu, if you want to call it that. The idea is that it's very easy to get into that habit and then slap a semicolon here, etc. So you know how to avoid the problem, okay? Put your opening curly braces here at the end of the line. That's one way to remind yourself. And second, just be mindful of this problem. Okay, we looked at it explicitly. We spent like a little bit of time on it. So that's the idea is that you're going to remember that there is a problem here and pay attention when you write your code. Okay, and if you do that, you're going to avoid those nasty little bugs. So we have two types of loops already in the C programming language, the while loop, the do while loop, and these are very common again in all programming language. You probably studied those loops also in the programming language that you studied before this class. And then there is a third type of loop, the for loop. So the for loop it really shines when you do counter control loops, okay? In theory, a for loop is equivalent to a while loop. So there is a difference between the while and the do while. I should start with that, okay? The difference between the while and the do while is that the while loop checks the condition first and then decide if it should go for the first iteration, and then it checks again, decide if it should go for the second iteration. So you make your test in the loop, your decision of whether you continue, you make it early in the loop, at the very beginning of the loop, as a matter of fact, okay? So you decide every time, am I going to go for another iteration before to execute that iteration? In the do while, you just go ahead and execute the body of the loop once, okay? And then you ask yourself, should I go for another iteration? And if it's true, then you execute the next iteration, and so on and so forth. So theoretically, if I was putting, not theoretically, but if I was putting here a value like 25, okay, int counter equal 25, counter lesser than 5, that would be false, I would never, ever execute those lines. I would skip the entire loop. But here, if I do this, if I set counter to 25, then what happens is that I execute at least the loop one time. And then I ask myself, should I continue? And I'm going to realize that 25 is not less or equal to 5. So I'm going to give up and get out of the loop. Okay. So this is the main difference between the while and the do while loop. Some people refer to the while loop as a test early type of loop, the do while being a test late type of loop. So what about the for? Well, the for is also a test early type of loop. So it's really, really equivalent to a while loop, okay? To illustrate that, I'm going to comment out this guy here for now because we don't need it. There we go. And to illustrate my point, I'm going to go back to counting from 0 to 5 included. There we are. And what I'm going to do exactly the same thing, but with a for loop syntax. And again, the for loop is one of those classical syntax that you find in almost every programming language, right? So first, my initialization of the counter, int counter equal 0. Then my condition, counter lesser equal to 5. Then my incrementation at the end of the loop, counter plus plus, and I'm going to write it short form like this, okay? So all of this is exactly what I had in the while loop. And these are the three parts that matter for a counter control loop, right? The initialization, the condition, and the incrementation that's supposed to happen at the end of each iteration. So I wrote everything on the same line, but that doesn't mean that everything executes once on that line. That's the peculiarity of the for syntax, okay? So to show you exactly what I mean, let me first fetch this here. I'm going to put the body of my loop. So the nice thing about the for loop is that the body of the loop doesn't have anything that has to deal with, incrementing the counter at the end or something like that. You really can focus on the work you're trying to get done, okay? But everything that has to do with the control of the counter control loop is all here. So how does that work? Well, exactly like the while loop. This part is executed only once. This part is executed only once before you start the loop. It's like when we declared our counter, int counter equals 0 here, right? So this is declaration of the counter if you need it, and initialization of the counter. If you already have a variable counter and you want to reuse it, then you don't have to redeclare the counter, okay? You just put counter equals 0 and that will work. If you declare, however, a variable here, you have to understand that that variable will only be available in those lines, okay? When you put a variable, you declare a variable inside the parentheses as a for syntax, that means, hey, I just want this variable as a counter for the loop. If you were trying to use it after, then it would not be available. So it's really like having like a very, very local variable that exists only for the sake of this loop, okay? So that's a little bit of a difference with what we can do with the while. So this is good actually. That allows you to spring, a little for loop, have a new variable, for example, I, and you don't want to pollute your code with this variable I, existing everywhere. So you declare it this way. That means that I doesn't exist before the for loop. It doesn't exist after the for loop, and I'm going to remove that out of the way. We really don't need it anymore. And that's it. So if I was trying to compile this, let me tinker a little bit here, run it. So 0, 1, 2, 3, 4, 5, that's the first loop, 0, 1, 2, 3, 4, 5. And I went a little over eager here. I got rid of our printf that was separating in two different lines the output. Okay, so here it is. Printf, it's back. All right, so I was talking about this int variable being declared here. So what if I was trying to say printf, after the loop, I is, and %d, and I want to display the value of I, okay? Seems reasonable. Let's save it, compile it. No, it's not reasonable. So what it's saying is I is undeclared, but we declared it. Yes, you declared it inside the parentheses of the for, which means the variable has what we call a scope. Okay, it has a part of the code where it's usable that starts here and ends there. So trying to use it afterward, it's just like if I didn't exist. If instead of I use the variable, the name, sorry, not the variable, the name counter, okay, you're going to see why I don't want to say the variable counter, because we have already a variable counter, right? It's been declared here. So the idea with declaration of variable is that when you declare a variable, it's going to exist by default in the block of code where it has been declared. So this has been declared here. It exists from the line, actually, that we declare up to the end of the current block of code. And it's available to all the block of code that are nested inside of it, like, for example, here and here. So what's happening here is that I'm trying to redeclare. Let me make sure that I save my file first. There we go. I'm trying to redeclare a new variable named counter, and it's still talking about I, which means I didn't actually save my file correctly, or no, there we go. There we go. I was still using an I here, so let me save again. GCC name.c, out. After the loop, I is 6. So this is an I here. This is not is I. So, okay. So what's happening here? So 0, 1, 2, 3, 4, 5, this is working. 0, 1, 2, 3, 4, 5, this is working as well. This for loop is working just fine. Even though I redeclared a second variable, also named counter. I thought I could not do that. Let me double check real quick. Int counter equal 42. Can I do this? Can I have like several declarations of the same variable? No. Previous definition of counter was here. Redefinition of counter, that doesn't work. So why is it working here? Because of scope. The idea is that this variable counter is usable, from the line it is declared to the end of the current block where it appears. And this one here, it's kind of like overloading, overriding it, okay? It's saying inside the for loop, I want another variable counter that's why I redeclare it. I want another variable counter that has nothing to do with the first variable counter up here, and it's going to have its own space in memory, it's going to have its own values inside of it, and so on and so forth. The easiest way to check that is, let's say that I set my counter here to 42, right, before to enter the for loop. Let's make sure that this variable counter is going to keep its value 42, and I'm going to be able to fetch it again after the end of the loop. And during the time of the loop, I'm going to have another variable counter that's going to start at 0 and go up to 5. Let's make sure that this works as we think it's working. And by the way, this is exactly what I mean by when I tell my student the best way to learn programming is by tinkering, okay? Writing very simple programs where you are not burdened with the complexity of the application domain, but you focus only on the property of the language. This is a very good way to strengthen your programming skill, okay? So let's see what's happening here. 0, 1, 2, 3, 4, 5. So this loop works still. 0, 1, 2, 3, 4, 5. That for loop worked just fine. After the loop, it should not be I now. It should be counter. Counter is, and then the value of counter. The value of counter is what it was before the loop. Okay. So it's like we had a temporary counter variable here that appeared that was used just for the sake of this loop. And when the loop was over, that temporary variable disappeared pretty much. It's no longer usable in my main. Okay? All right, so that notion of scope of variable, we're going to talk about it like once in a while, throughout the entire course to clarify, when and where variable are usable. The reading assignment is also going to go over this, like if you never encountered that ID before, but the truth is that you kind of encountered it before when you learn to program in a different programming language, right? Every programming language has that concept of scope of variable. When you declare a variable, it's going to be available only in a certain part of the program. And languages like Python, where they don't force you to declare the variable, you just start using a variable, and the first time you use a variable, poof, it comes into existence, right? Well, it's kind of the same idea for. From the first time you use a variable, to the end of your code, you can use that variable, but there are rules, like for example, if you call a method, that method or that function in Python cannot see the variable that you add in another function. All of those constitute scope rules, and we're going to go over them as they pop up in the C language as well, okay? All right, so what do all of those loops have in common? The while, the do while, the for. Well, they have a condition, and this is what we call a continuation condition. What does that mean, a continuation condition? A continuation condition means if the condition is true, I keep going. If it's false, I stop. Okay? So for example here, while I test my condition, if it's true, I enter the loop. With the do while that I erased, but it was there before, with the do while, right, I would execute first the body of the loop, then I would ask myself, do I need to continue? Okay. And then for the for, it's the same thing. I initialize before to start the loop my counter. Then I ask myself, should I enter the loop for the first time? Counter lesser than 5, true. Then I execute the body of the loop. And when I reach the end of the curly brace here, I jump back here and I execute the incrementation of the loop. So yes, the for loop is a little bit more wonky, right? We execute this before to start the loop one time. Then we test, execute everything in the body of the loop. Then we increment or decrement or whatever we're doing in this part here. Then we test again, execute again what's inside the loop. Then again, go and execute what is here. So this part here is what needs to happen every time you reach the closing curly brace, right? Every time you're done with one iteration of your loop. But beside this little jump around, way of executing things in the for syntax, all of the conditions here have the same meaning. What if you want to get out of the loop when a condition is true, like detect what we call an exit condition? If this and so is true, then I want to get out of the loop. Well, you cannot do that with this syntax, right? You would have to negate your exit condition and turn it into a continuation condition. What if I want to get out of the loop like in the middle? Like I want to detect after I displayed counter, for example. I want to do a if statement, detect if counter, I don't know, is a multiple of 2 or something like that, whatever condition you can imagine here. And if it's true, then I want to exit. Well, we do have a keyword that allows us to do this. So let's do exactly that. Okay, let's say I have a counter control loop here. Okay, and I'm going to remove that counter equal 42 because we don't need it anymore. We don't need that anymore either. I have two counter control loops here that start counting at 0 that go up to 5 by increments of 1. And what I'm going to do here, I'm going to say if, so my counter is counter modulo 2 equal 0. So that just means pretty much if counter contains a value that is even, a multiple of 2, okay? If counter modulo 2 equal 0, open, close curly brace, what am I going to do if that's true? I want to get out of the loop. And I have a keyword to do exactly that, break. So when the keyword break is executed, the program is going to look around and say, okay, this keyword break is in the if statement. That if statement is in the while loop. So, okay, this is the first loop that I found, by zeroing my search, from break outward. And this is the first while loop that the first loop, sorry, that I found. So this break statement is going to catapult me out of the loop on the first statement after the end of this loop. If I am inside of a for loop, it's going to work the same way. I could say if counter modulo 2 equal 0. There we go. Then if that's true, and this becomes my exit condition, a condition which, when it is true, causes me to exit the loop, okay, as opposed to a continuation condition like this one. If counter modulo 2 equals 0 break, so the first time I encounter a multiple of 2, I get out of the loop and I jump past the end of the loop to the first statement that comes afterward. Let's run those things real quick so that you see what they do. GCC, a.out, they don't do anything. So what's happening here? Well, I start counting at 0. 0 modulo 2 happens to actually yield a result of 0 too. It's 0 as well, sorry. So what I'm going to do now, I'm going to start counting at 1 so that my loop doesn't exit immediately, because when I do 0 modulo 2 and I find out that it's 0, then I break out of the loop and I'm done in both cases, okay? So I save this, GCC, a.out. So what's happening? Int counter equal 1. 1 is lesser or equal to 5. True. I enter the body of the loop and I execute the entire body of the loop. Well, not really the entire body of the loop, you're going to see. If counter modulo 2 equals 0, so if 1 modulo 2 equals 0, nope, that's not true. Okay, 1 modulo 2 is not equal to 0. So I skip that part for now. I display the value of counter, that's 1. I increment counter, now counter is 2. I go back. Is 2 less or equal to 5? True. If 2 modulo 2 equals 0, this is true. Divide 2 by 2, you don't get a remainder, it's 0. So now I execute break, which catapults me here. So I display pretty much a new line here after the 1, and I start doing the same with my second loop. Int counter equal 1, so a new variable counter that's going to be used only for this loop, initialized to 1, just like the previous one. 1 less or equal to 5 is true, so I execute the body of the loop. If 1 modulo 2 equals 0, that's false. I execute what comes after this if statement, display 1 on the screen, here we are, okay? And then I increment counter by 1, so now it's 2, and I go back to the beginning of the loop by testing the condition. 2 less or equal to 5 is true, I enter the body of the loop, I execute this, counter modulo 2 equals 0, so 2 modulo 2 is equal to 0, therefore I execute the break, and I find myself out of the loop right here, okay? Display a new line, and then exit the main method. So we have a way to exit the loop kind of sooner. We have the way to exit the loop with a condition that when it's true, that means we exit. When it's false, that means we continue, which is the opposite of the type of condition that we use between the parentheses of a while, of a do while, or a for syntax. And generally, when we introduce that keyword break, we also introduce its counterpart. There is another keyword called continue, and it does something different than break, of course, but it's used in the same kind of scenarios, right? It's going to be used generally after or inside an if statement that is itself inside a loop, and it has to do with, how we continue the execution of the loop. So whereas the break statement catapults you out of the loop, the continue statement means when this gets executed, I jump to the end of the loop. I skip everything else that was remaining in the body of the loop after the continue keyword, right? So I skip this orange part, and I jump directly to the end of the loop, and then I rewind and I test again. It's kind of like, instead of continue, you could think of it as skip. Okay, skip to the next iteration. That would be maybe an easier name to remember what it does, okay? But it's a longer name, so continue is shorter and you'll get used to it, so don't worry about that. But the idea is, it's like break, right? It alters the way that things execute in our loop, but instead of getting us out, it just makes us keep whatever was left in the loop and go directly to the next iteration. So let's see how this works. What is this going to do? So let me make sure that the file is saved. Compile, run. So here I get into an infinite loop. So let's check exactly what's happening. While, so counter is equal to 1, okay? While 1 right now is less or equal to 5, well, that's true. So I enter the loop. 1 modulo 2 equals 0, that's false, okay? So I go here, I display counter, then I increment counter by 1, so counter is 2. I go back here, counter 2 less or equal to 5, that's true. 2 modulo 2 equals 0, that's true. Continue, I skip this, I end up here, and then I rewind. 2 lesser or equal to 5, true. 2 modulo 2 equals 0, true. Continue, skip all this, go here, and you see the pattern now? Every time, once I reach 2 here, every time I trigger continue, I'm skipping over this line, I'm skipping over the next line, which means I'm never incrementing any more counter by 1. And that's a problem, right? That's a problem because, that way we're going to be stuck at 2 and we're never going to reach 5. So that's the essence of an infinite loop. Let me add something here real quick. This is like a side topic, but I'm going to do this right now real quick to show you something interesting here. Some of you might have been wondering, well, why is it that when you go over the trace like that, you tell us that printf is executed once, and we didn't see a 1 here? So this has to do with buffering. This is a topic for another video, okay? But the idea is that when you tell your operating system, hey, my program wants to display printf %d counter, it's not going to jump through the hoop and display counter right away on the screen. It's going to make a note that you want counter to be displayed on the screen. And it's going to wait. It's going to wait that it has enough characters to display so that it can make it an efficient operation to go ahead and display something on the screen. So here, we just display that one character, 1, and then we don't display anything anymore. We're like in an infinite loop that does nothing. So the operating system say, well, that can wait. I can wait to display the 1, you know, I'll take care of that once I have multiple things to display so that I can make it efficient. So by putting a \n here, I flushed the output. I said, okay, I'm done with the line. And when I'm done with the line, generally the operating system is going to say, okay, let me display whatever is in the line, even if it's not much, okay, to get it over with. And that's exactly what happened. It displayed the 1 that it was not displaying before. So yeah, that's what I mean by little details can matter a lot, okay? You would look at this trace here and you would not see the 1 and you would scratch your head, you know, thinking like, well, how come it doesn't display ever that printf counter when counter is 1? Because as far as I understand how the language works, it should, and it didn't on the screen, okay? So that happens in other programming languages. C is not the only one, okay? The buffering is a thing that happens across all programming language. You just have to be aware of it when you are trying to trace like that things by hand. But very soon we are going to learn to use a debugger, which means we are no longer going to trace like that, rely just on the output on the screen to trace through a program. We're going to do that in a much more principled manner, in a manner of speaking, okay? So going back to this infinite loop, that's a nasty business. So the continue works, but in that case, you know, I should probably not use continue because it makes me skip also the loop incrementation. So you know what? This is not really optimal. I'm going to comment out this loop. I don't like it. It's actually an infinite loop. It helped me understand continue, but you know, I would not do that normally. Let's compile the new version. Now I want to see what the for loop does. And I told you the for loop is really equivalent to a while loop. Okay, as a matter of fact, we wrote this for loop to be equivalent to the while loop. And that is true 99.999999999, as many nines as you want, % of the time. And then there is one exception. Well, guess what? This is what we're going to deal with right now. Okay, I run a.out. So while, no pun intended, but while this while loop is an infinite loop, when I use continue seemingly in the same way in the for loop, this loop here is not infinite. This loop works, and it keeps counting like that, skipping, you know, everything that is multiple of 2. So it counts 1, then it skips the 2, counts 3, then skips the 4, then counts 5. Okay, so this is working. Why the difference? Well, it has to do with the meaning of the keyword continue. The meaning of the keyword continue is jump to the end of the loop. When I jump to the end of the loop from here to here, I skip all of this, which includes the incrementation of the counter variable. When I jump to the end of the loop, skipping all this here, and reaching the end of the loop here, I skipped only the printf. Why? Because the incrementation of the counter, which happens at the end of every iteration, is safely stashed away in the syntax over here. And while it's meant to be equivalent, that means that it's not skipped by the continue. This, what is highlighted in orange right now, happens after I reach the end of my loop body, after the end of each iteration. So this is going to happen just because of the syntax being a little bit different, and that makes all the difference, right? So be careful about this. This is again a small detail, but that has a lot of potential impact on the correctness of your programs. With this, we covered actually everything, like the 3 types of loop in the C programming language: for loop, while loop, do while loop. We covered their similarities and differences with the same kind of loops in other programming language, and I try to draw your attention, as usual, on the pitfalls, right? The things that are most likely to go wrong, or that you are most likely to overlook when you're just learning to program in C. So we're going to wrap it up for this video. As usual, post your question, forum, Piazza, whatever we're using this semester. Come to office hours. The TA and I are here to help you, mull over that material and make sure that you're comfortable with it by the time you are taking the exams. So thank you for your attention again.